Hey everyone. Okay, great. Charts are up. So I'm Ashley Korzun. I'm from NASA Langley Research Center. I'm currently wearing a handful of hats, but principal investigator for Plume-Surface interaction in kind of variety of functions, including a larger scale ground test, vacuum ground test that we have upcoming for the HLS program. I also wear a little bit of hats for the Space Technology Mission Directorate, or NASA STMD. So I have just a couple of charts where COA on this. What I'm going to talk about is we don't have a schedule for implementation yet. We don't have a budget. I'm going to show you what is being proposed. We're in the process of going through a reorganization of NASA's Space Technology Mission Directorate. So this is one of the main mission directorates at NASA. And the function of STMD is not to do work for missions, but it is to build and develop the set of capabilities that are then absolutely necessary to go off and execute those types of missions. What I'm going to stay is kind of focused on the moon here, but what we're pursuing for Plume-Surface interactions is absolutely not limited to the moon. I think we all can appreciate how environment and destination dependent and vehicle dependent, and name your other 4 favorite parameters, and you're just beginning to scratch the surface with PSI there. But what I'm not going to touch on is I think we've got a number of folks on that are familiar with a prior PSI project that was funded by the Space Technology Mission Directorate. That was a 3-pronged approach. We had all 3 legs of the stool represented in that project, from ground testing to flight focused and prototype instrumentation development, and a lot of investment in some specific paths for computational modeling and simulation. That project ran from 2020 to 2022. And if we are able, to get this STMD reorganization up off the ground and get some budget to go with it, we are absolutely planning to bring PSI back. So in that interim, just at the end, I'll talk a little bit about a graduate fellowship program that has a deadline that has not passed yet. It's called NSTGRO. These are awesome graduate student fellowships, and I would love to see a lot more proposals coming in there for PSI. So we'll talk a little bit about that at the end as well if you have any further questions. So let's go to the next chart. So the Space Technology Mission Directorate was previously organized by technology readiness level, or TRL. You had kind of very low TRL, you had game-changing kind of mid-TRL type of things, and then the big boy stuff, the technology demonstration missions. What we're doing now is we're actually going to decompose this into what we call functional domains. And the one I have boxed there in red, big box, is land. You could think of this as the entry, descent, and landing box, or EDL box, but this is land. Within that, we've got 4 capabilities in this domain, one of which is landing systems and environments. This is where PSI this is where we're planning for this to live. There's a bunch of familiar names, working this kind of development and formulation phase for this activity. Wesley is helping us as the PI for this. I'm serving as a portfolio architect, and our portfolio manager is Rob Maddock, who you'll hear from, I believe, later today on this, as we try to pull all the things that we've been talking for years about doing with PSI and collaborating with others, and just doing the integration of this kind of capability development level work is all proposed to live here. This is where the roadmaps live. This is where all of that kind of good stuff gets captured. Let's go to the next chart. So what do we envision as being part of what we're calling landing systems and environments? Again, think of this as 90% PSI. There was a survey that was sent out to the public, to industry, to academia, as well as internal to NASA. And what they're doing as part of the Space Technology Mission Directorate's reorg is they want to identify shortfalls, and they want to get feedback from the community at large to understand a rough prioritization of these shortfalls. PSI falls on that list. And in terms of those survey responses, PSI did pretty, I'll say pretty well, by which I mean we were pretty high on that list. as given just the number of people that have joined this workshop here, we've got a lot of interest in PSI. There's a lot of need for PSI. PSI has been a risk on every lander mission since the inception of NASA, without exemption. It is formally carried no matter where you're going. If you're going to Mars, you're going to Titan, you're going to the moon. We don't have one for Da Vinci, even though we are going to the surface of Venus, but no engines on that one. So PSI is something that even once we have these fully developed and validated generalized modeling capabilities, if you think of kind of what the end of the road potentially looks like, this is still going to be a really challenging environment for any type of system that we're trying to send to the surface. And on the flip side, if you are then subsequently trying to ascend off of the surface, these environments are absolutely going to be there. Big interfaces with the dust community, surface ops, site planning, all of those types of things are big interfaces to the PSI capability. PSI generates an environment. Lots of other people and disciplines are seeking to understand that environment and then take those as inputs and kind of continue outward in each of their respective design directions. So the way this starts is that we pull existing content in the Space Technology Mission Directorate, and that right now has been limited, though, lots of stuff going on there, to flight instrumentation. So you're going to hear about scalps, where we're going with scalps, what are the different versions of scalps that we've got on the table, as well as other Plume-Surface interaction instrumentation. Something that is funded by HLS, that's the Human Landing System Program. Those are the gigantic, large building sized landers headed to the moon for crew and cargo. Under the Artemis program from our partners at SpaceX and Blue Origin, we're funding a very large compared to what we've done previously, small in comparison to the actual size of these landers, vacuum scale ground tests to be conducted really over the next 12 to 16 months at NASA Langley Research Center in our 60-foot diameter vacuum sphere. That's HLS funded. So that's definitely ongoing. Lots of data will be made available as a result of that test, but not part of the STMD portfolio. What we are envisioning is to go back. We really liked the structure that we had the last time we had an STMD project. We are tackling all three legs of the stool, and I've got a chart coming up next that'll summarize this just a little bit in a little bit more detail. But you have to have testing. That can mean everything from more fundamental tests, things focused on a single effect, more canonical in nature, allowing you to interrogate very specific questions, up through additional subscale testing. Then, of course, you've got modeling and simulation. All of that has to be, continued to mature and develop. And then it's got to be rigorously validated. We've got to have quantified uncertainties. We've got to understand what this looks like when every model that we use is extrapolating in some sense of the word. This is a portfolio of modeling capabilities. It's not just the most, complicated coupling and highest fidelity. This includes everything from engineering models and test-derived analytical relationships, all the way up through, the challenging full, four-way coupled models. And then lastly, a lot has changed. Things have advanced a long way in terms of sensors, potential instrumentation. How do you use different types of information to attain these really unique data in a test or flight environment? So we want to go back and we want to revisit, hey, what is the current status of flight instrumentation, sensors, diagnostics? How do we get the data that we need if we want to understand PSI and validate our predictive capabilities? So let's go to the next chart. I've mentioned the three-legged stool quite a bit. So for those that aren't familiar, I did just want to put this in here. What does this actually mean? This is the triumvirate of modeling and simulation, experimental data, and flight data. We are not unicyclists. You cannot survive just on flight data. No, that is not to say flight data is not insanely valuable, but it represents a single point. We can't control flight environments. A lot of times it can be difficult for us to measure everything we need to know with the necessary accuracy associated with it. And then everything you have is, of course, tied to just that one trajectory, that one vehicle design, that one ConOps, all those sorts of things. It's kind of the cherry on the top of the sundae. Experimental data. This allows us to do a lot of different things that set us up for the development and subsequent validation of modeling and simulation capabilities, but the development of the data products themselves, those can be directly useful. You can do valuable testing. It's highly parametric. It's a companion to what you can do in the flight environment. And then up at the top here, you have modeling and simulation. And again, this fills in all of the gaps. You know, we're talking about testing PSI for the moon. We will never be able to do a lunar PSI test here at Earth. Sounds pretty obvious, but right, we're always going to be missing things. Even if we did the best possible test in the world, we're not on the moon. And there are things we will never be able to do. You will always be doing some sort of extrapolation. So we have to fill in those gaps utilizing modeling and simulation. Let's go to the last chart I have here. So just in summary, all of this is proposed. It is in work. We're definitely in a formulation phase. We're trying to get roadmaps updated, define where do we want to go from here. But NASA's Space Technology Mission Directorate is planning to reinvest in Plume-Surface interaction capabilities. This is huge for us. A lot of us were, to be completely frank, pretty disappointed when the bottom fell out in 2022 due to budget situations that we ultimately don't have any control over. But I think it's just coming back full force that there are a lot of unanswered questions on PSI. There are a ton of needs in this area to allow us to enable, not just human spaceflight objectives, but a ton of science objectives as well as architecture planning. As part of what we hope to do within STMD, this is not predicting mission environments. Those will continue to remain in the domain of NASA's Human Exploration and Operations Mission Directorate, or HEO. Well, actually, you know what? My coffee's not kicking in. We've changed that. We now have STMD. So I'm a few years out of date there. We'll go with senior moment. But that is where our crewed exploration programs, that's STMD. And then we have our Science Mission Directorate. So different destinations, different sets of objectives. The Science Mission Directorate is absolutely focused on sending and doing great science at the moon as well. STMD is there to help make sure that we're going to be able to have those capabilities ultimately be successful. What are the types of things that we're interested in? Again, those three things: testing, modeling, flight, instrumentation, and I would expand that to include sensors and diagnostics. Not everything that we need to capture necessary data products is going to be on a path to becoming a flight instrument, and that's okay. We still need those data to understand the physics at play here. What is driving all of this? I always put this quote in here because I actually had this come up at a mission review. It said, "We've never lost a lander to PSI." I'm not going out on too much of a limb here to say that that is not an acceptable risk posture. We have experienced lander damage from PSI. We have absolutely experienced increased risk on approach to the surface due to the inability to see anything. We know this can spoof radar. We know this can degrade sensors that you're depending on for safety and mission success. So we're not going to accept that we've rolled the dice with PSI, particularly as our landers and ConOps and how we want to do exploration is really moving us outside of the box of past flight experience. So with that, I encourage you guys to stick with us, see where we're going from here as the STMD reorganization moves along. But in the meantime, for those of you that have graduate students, I highly recommend the NSTGRO fellowship. And I believe it's typically a November 1st deadline for those proposals. So with that, let's see if we've got any questions.
Thanks, Ashley. We have 1 minute for questions. If anybody wants to type anything into the IO, Wesley's put the question there. I think, from my perspective, it's definitely great to hear about the funding being back in place within STMD, especially for things like NSTGRO and opportunities like that. And I think it'll be interesting to see today how we have sort of folks working on these different objectives in the different areas and how they tie into what you talked about. So great. Thanks, Ashley. We'll go ahead and move to our next speaker.